Now that we've learned a little bit about how solutions are made, what kinds of things will dissolve, which things won't, and how that process of solvation works, the next thing we need to learn about is called molarity. Molarity is a way of describing how concentrated that solution is or is not. And you've seen the numbers for molarity almost this entire year. Anytime that we've had an acid bottle that you've used for lab and it's got a number on the front, that's the molarity number. So today we're going to learn what that means and how you calculate it. Molarity is a unit of concentration. In other words, molarity is how we measure the concentration of a solution. Concentration describes the amount of solute dissolved in a given amount of solvent. So how much stuff do you have dissolved in a given amount of solvent? Usually water. For example, when you make coffee in the morning, you have to decide how many grounds do you put in the basket versus how much water do you pour in. If you put in a lot of grounds for the amount of water, your coffee will be very concentrated. If you don't put in very many grounds for the amount of water, then your coffee will be very diluted. So you decide when you make your coffee in the morning how concentrated or how diluted it will be. And when we do that with chemicals, we can actually figure out a number for how concentrated or how diluted something is, and we'll call that molarity. Molarity is the unit we use to describe concentration. Molarity is defined as the number of moles of solute per 1 liter of solution. If we go back to the coffee example, you'd be calculating how many moles of coffee grounds did you put in per 1 liter of water. So how many moles per liter? If we write that out to put it into more of an equation format, we would have molarity, and the symbol for molarity is a capital M, is equal to moles of solute per always means divide liters of solution. If we just write that out with the symbols then, make it a little shorter, molarity equals moles over liters. And this is the equation that we use. So let's do some examples. A salt solution has a volume of 152 milliliters and contains 0.90 moles of NaCl. What is the molarity of the solution? We know that molarity is equal to moles divided by liters. So the first thing that we'll need to do is change 152 milliliters into liters. You might need to remember your metric system. King Henry died drinking chocolate milk. Liters is one of our base units, so it's in the middle. To go from milliliters to liters, we go 1, 2, 3 spaces to the left. So that gives us 0.152 liters of solution. We're given the moles in the question, so now all we need to do is plug in our numbers. Molarity is equal to moles divided by liters. We need to keep 2 sig figs here because of the 0.90, and that gives us 5.9. So when you write your final answer, you write 5.9 with a capital M at the end, and that stands for molarity. Example 2. A 3.0 liter aqueous solution contains 45 grams of Ki. What is the solution's molarity? Aqueous means dissolved in water, and we are given in the question liters of solution and grams of solute. So before we can use our equation, molarity equals moles over liters, we'll need to change grams of solute to moles of solute. You already know how to do this. We've been doing it since October. 45 grams of Ki. We need to cancel the grams, so where do they go? On the bottom. Where do we get the number for this? Look it up, periodic table. Add up a potassium and an iodine. You get 166.00, and that is for 1 mole of Ki. Divide, check your sig figs, 0.271 moles of Ki. And now we're ready to use our equation. Molarity equals moles over liters. So 0.271 divided by 3.0. Check your sig figs. We need 2. Molarity is 0.090, and you always have to have the capital M at the end. And there's your final answer. Example number 3. How many moles of NaCl are in 1.5 liters of a 3.0 molar NaCl solution? What mass of salt is this? Now we have 2 questions, and the first one's been turned around a little bit. This one is almost backwards. We're still going to start by looking at our equation. Molarity equals moles over liters. But this time, we're being asked for moles. We're given liters, and we're given molarity. So we can go straight to our equation and plug the numbers in, but we're going to be solving for moles this time instead of solving for concentration. So we have 3.0 for our molarity. That is equal to X number of moles divided by 1.5 liters. Multiply both sides by 1.5. .5 cancel on that side, and you end up with 4.5 moles. 2 sig figs, both of those had 2 sig figs. So this is the first part of our answer. For the second question, we're being asked, what mass of salt is this? So now we need to take our moles and convert to grams. Moles need to cancel, so that goes on the bottom. This is NaCl, so we look up 1 sodium plus 1 chlorine, and you get 58.44 grams. Multiply across. Calculator shows you 262.98, but we need 2 sig figs. Start at the big end of the number. Keep the 2, keep the 6. The 2 next to it says round down, so this becomes 260 grams of NaCl. And we're done. That's it for the notes. Now you have a practice worksheet, and some of the questions will be just like you've seen in the examples, and some of them will be a little different. Good luck.